Hello, thanks for tuning in. Picture yourself on a human resource analytics team. Your objective is to optimize compensation planning by predicting which prospective hires are likely to expect premium salaries. Relying on intuition often leads to inconsistency and budgetary misalignment. The predictive solution for this could be by training a machine learning model in a low and no-code environment on robust historical data, allowing for proactive and competitive offer management. For this, we'll be leveraging an adult income dataset from the US to build a binary classification model to predict whether an individual earns more or less than $50,000 annually. The dataset comprises over 48,000 entries and includes 14 distinct attributes, such as age, work class, education, relationship, sex, race, or native country. Before we start with the HR analytics use case, first, a short overview how to use KNIME as a low-code, no-code platform. With KNIME, you can simply drag and drop functional blocks called nodes from the repository onto a visual workflow canvas and connect them to establish the data flow. Each node performs a specific task, such as reading a file, filtering rows, doing some statistics, or for example, training a machine learning model, which you can configure through a straightforward graphical interface. For example, we can just drag and drop the node C3 reader onto our empty canvas. After that, we have to put in our dataset onto the source and apply. After that, for example, to gain some insights in the dataset, we can just drag and drop the node statistics onto our canvas. Then we just have to connect those two nodes. Once our workflow is built, you click Execute to run the entire pipeline, allowing you to blend, analyze, and visualize data without writing a single line of code. If we then click on the Statistics node, we have a good overview about the dataset we just read in. Next, we move on to our HR analytics use case. Here you can see the whole low-code, no-code workflow of our HR analytics use case. Let's jump into step 1. The workflow begins with the import of the adult income dataset using a CSV reader node. This step introduces the dataset that forms the basis for all subsequent machine learning activities. The imported dataset serves as the foundation for both model training and evaluation. Following data import, descriptive statistics are generated and displayed using a statistics node and the table view node to visualize. This stage enables to gain initial insights into the dataset and become familiar with its structure and characteristics. After step 1 and step 2, in step 3 the dataset is divided into training and test data using a table partitioner node. Following common machine learning practice, 70% of the observations are allocated to the training dataset, while the remaining 30% are reserved for testing. Furthermore, in step 4, model development is performed using KNIME's AutoML component. The AutoML node automatically evaluates multiple machine learning algorithms and configurations to identify a suitable predictive model. After the AutoML model process is completed, the selected model is executed and evaluated through Workflow Executor node. Because equity is absolutely critical in HR analytics, we dedicate a significant portion of our analysis to fairness. In step 5.1 is the first evaluation stage. Model performance is analyzed separately for different racial groups. Using row filter nodes, observations are filtered according to race categories, black and white. And model performance is assessed using once again scorer nodes. The second evaluation stage is shown in step 5.2. Here we apply the same procedure to gender groups. Performance metrics are calculated separately for male and female individuals to highlight potential differences in model behavior across demographic subgroups. In the final stage, the trained model is deployed and applied to a set of hypothetical prediction scenarios. The first deployment scenario focuses on race. Two synthetic profiles are created that are identical in all attributes except for race. Then the resulting income predictions are compared. The second deployment scenario, shown in step 6.2, focuses on gender. Two additional synthetic profiles are created that differ only in terms of gender and relationship status. One profile represents a male individual with a wife, while the other represents a female individual with a husband. Predicting income is then compared for the different groups. Thank you for watching.